Okay, we'll be looking at the next topic, skeletal systems. When we say skeletal systems, it means this: bones, cartilages, joints, okay, and basically in the human body there are three types of tissues. Bone tissue, which is hard, rigid. Cartilage tissues, which is not so hard, a little bit rigid, not so rigid. And there's also something which called hemopoietic tissues. Those are not hard at all. Usually within the bone. Okay, and these are the tissues that form blood cells. Okay. Let's first look at the bones. Mainly we will be looking at the bones and the muscles. Everybody has exactly 206 bones. Okay. Once in a while, you may have some extra or something in short, but that's not regular. And the 206 are in pairs. Okay, there's one on the right side, there will be the other one on the left side. Okay? And there are different shapes. Okay? The first type is long bones, such as the humerus, this one. The bone within your upper arm is called humerus. Okay, it looks long, right? Such as radius. The arm, the bone, there are two bones within your forearm. Within your forearm. This is upper arm, this is forearm. Radius is a little bit larger in radius, a little bit larger radius. And there is another one here, a little bit smaller, which is ulna. Okay, ulna here. So there are two long bones here. So if you look at this skeleton here, it's like this, right? Humerus for the upper arm. Okay, and this for the lower arm. Okay, there's one radius and another one ulnar. Okay, and it is very interesting that we need two here in order to make this motion, to turn. Okay, as we will see, this is called pronation. Have we discussed this already? In chapter 1? No, okay. This is, you can turn your forearm. Okay, you can turn your forearm. When I say I turn my forearm, I don't mean I turn my hand. The hand is still fixed. The hand doesn't move with respect to forearm. The hand, the relationship between the hand and the forearm still fixed. And then you can turn the entire forearm. It is really because there are two bones here. And one of the muscle attached to one bone. And the other muscle attached to the other bone. Because of this structure, if one muscle works, then it will try to pull one bone. And the other bone, it doesn't do anything. So then you have this movement, this motion, this rotation. That's the pronation. We'll see as we'll see. So there are two bones at the lower. Okay, this is called lower extremity, upper extremity, at the lower arm. Okay, and then femur for the thigh, or for the thigh. Thigh is the upper leg, the upper part of the leg, upper leg. Femur. And then similarly, there's a tibia and fibula. There are two. Okay, why do we need two? Because of the need for rotation, for need for this kind of rotation. Tibia and fibula. These are long bones. And then we also have phalanges. These are finger bones. Okay. Let's see. Yeah. Phalanges. These are long bones. Okay. Finger bones. They're smaller, but the shape is still long. It's a long shape. Okay. Also, we have toe bones. Toe bones also long bones. Okay. And then we also have the metacarpal bones and the metatarsal bones. Okay. Metacarpal refers to the hand. Metatarsal refers to the foot. Okay, those are also long bones. Okay. Okay, finally clavicle. This is clavicle. It's also a long bone. Let's see. Here, this one. This is long, right? Long bones. Okay. But you may think that the rib is long bone, but no, the rib is actually flat bone, because they are really flat. Okay. So clavicle is long bones. Okay, and then we also have short bones. The carpal bones, these are carpal bones. Are short bones. Similarly, in the ankle, we also have tarsal. Okay, very similar. So these are short bones. And then we have flat bones. They are kind of very flat. Okay, this scapulae, we have one here and the other here. That's scapula. Scapular is here, this one. Okay. It's flat. Okay. Yeah. It's flat. Okay. And then we have ribs. Yeah. Ribs is flat. If you look closely, it's very flat. Rib. Okay. This is a rib. And then we also have the skull. It's also flat. Skull. Finally, we have something called irregular. Irregular. The shape is different. Okay. For example, vertebra and sacrum. Okay. Let's see. Yeah, vertebra and sacrum. Vertebra. Each of this is one vertebra. Each of this is one vertebra. It looks like this. Okay, we'll look at this in more detail. It looks really like this. And then sacrum. Okay. Irregular. Okay, this is a posterior view of the skeleton. Okay. Remember anterior and posterior? Looking from the back. Posterior, okay? And we can consider the human body, the human skeleton, into two different structures connected together. We have a main axial skeleton. This. The main axial skeleton, the major function is to protect the organs. To protect the organs. For example, the rib. The ribs here, right? They protect the heart, protect the lungs inside. Okay, the skull. The skull is to protect the brain, right? Okay, so the main axial is extremely important compared to the so-called appendicular skeleton. Appendicular refers to the lower extremity. That's the lower leg plus lower foot. And or an upper extremity. So it looks like these are attached to something important. Axial. This is axial, and these are appendicular. Okay. If there is a damage to the appendicular skeletons, usually it's not. You are still able to function. Okay. But if there is anything, okay, damage to the actual skeleton, usually it's okay. It will make someone very difficult to survive. Okay. Basically, the bones, the skeletal bones, have these functions: support. Okay. For the appendicular, there's a main function which is movement. Okay. So protection. Okay. The actual skeleton, the main function is protection. The appendicular structure, the main function is to support also. also for the axial, to support the weight of the organs inside, to support, okay, the upper body for the two legs, okay. The legs have to support the entire weight of the upper body, right? Okay. So support, protect, move, the main function of the appendicular structure is to move. Okay. And then finally, bone marrow. Bone marrow are housed within the bone. Okay. And then bone marrow are very important because the red blood cells, okay, are formed there. Finally, the bone can store calcium and phosphorus. These are very important, okay. There is a famous biomechanical law, okay. If you pay a lot of money to SpaceX company, okay, they will send you up there, I think next year probably. There's a couple per people already paid. They're waiting. And once you're sent to the space, a couple weeks, what's going to happen? Because it's weightless up there. Okay? So you don't need the support. Your body is so smart. So the calcium you'll be losing your calcium because you don't need it. Calcium is the kind of ingredients for your bone to make your bone rigid, hard. Okay? So there's a Wolff's law. If you don't need it, if you don't use it, okay, that means you don't need it. You don't use it, that means you don't need it in your body. So you'll lose it. And that's the first thing you will lose in space, calcium. Similarly, if you don't use your muscle, you always sit there, you're always doing this, working, playing with the game and computer. You don't walk anymore. You don't exercise anymore. You don't use your muscles anymore. You don't use it. So you are telling your brain you don't need it. So you'll lose your muscles. You'll lose your muscles. Okay? And you don't see this when you are young. But you're actually losing your muscle every year. Maybe 5%, maybe 10%. And when you grow older, into middle age, 30-something, 40-something, you will begin to experience it. You feel it. You have back pain. Why do you have back pain? Because your muscles are already lost. And there's not enough support, not enough function. And all the joints begin to compress together. Okay? So if you work so hard, play so hard, without exercising, okay, in your 20s, that's probably fine. In your 30s, you begin to experience something. And then as you begin to exercise, you are giving the body more stress. You begin to jog. And starting from that moment, you are giving the body more stress. And then you will begin to experience sports injury. That's why. Because you've been too lazy for 20 years, for 10 years. You lose your muscles already. Okay, so for training purpose, okay, you need to have a good schedule. Otherwise, you're actually hurting yourself. Okay. How about brain? We have a lot of neurons in our brain. If you don't use them, that means you don't need it. You don't need them. So does that mean that you will lose your memory faster? Similar principle, right? So the more you use them, you're actually activating them more. They're helping you. And we've been seeing this cognitive function being lost faster than ever, because we are now using the mobile phone, the smartphone, the computers. We don't try to memorize anything at all. We don't even try to memorize everyone's names. We don't try to memorize your own phone number. So when somebody asks, what's your phone number? I have to pick up my phone and take a look. That's my brain. I don't use my actual brain. I use my smartphone brain. That's a kind of potential danger, because you don't need it. You don't need that. You don't use them. Eventually you lose it. Okay. What about cartilage? Cartilage is something transparent, okay? And it's not so hard, but it's still firm, and it's elastic, flexible, and it grows very rapidly, okay? There are several major cartilages, okay? The first one is haline cartilage. Okay, they cover joint surfaces to reduce impact. Haline cartilages. Okay, usually they cover some of the joints. Okay, some of the joints. It's haline. Fibrous cartilage. Okay, and they will provide some rigidity and tensile strength. Okay, such as those between the disc, which is called intervertebral disc. Okay, it is shown here, this kind of thing. This is intervertebral disc. Okay, it's fibrous. Okay, these material support your dampening the vibration pressure. So if you jump, okay, look at this. If you ask this guy to jump, okay, and these absorb that kind of compression. Okay. There's also something called elastic cartilage. Okay, they are both elastic and also firm. Okay, such as something in your ears and nose. In your ears and nose, there's also very tiny cartilage. Okay, cartilages all occur at the place at somewhere near the joints, where the bone. Joint is bone to bone. That's called joint, right? Combine. The meaning of joint is actually combining. So joint is a place between bones. So within your ears, there's also a very tiny bone. You hear something, some explosion, like a thunder or like a gunshot in this room. It's very loud. The bone will immediately react. Okay, so that your inner ear contains something. Okay, it's a very thin film that receives the pressure, the air pressure. So that bone will hold it so that you don't feel it. Otherwise, it's too big. It causes damage. Okay? And for that ear bone, there is also a cartilage. It's both elastic and firm. Okay, the joint. Okay, another thing is the rib, this part is cartilage. Okay, the white one, the white part is the bone, and this part is the cartilage. And sometimes they break. Okay, and this part is the fastest growing body tissue within our body. The fastest growing tissue. They grow much faster than the rest of places. So if you hit it during the sports injury or during a car accident, then the doctor will tell you, oh, you break your rib. And most likely they don't do too much to it. You go home and take a rest. And then they grow back. They grow back very quickly. Okay? Okay, joint. Joint is the junction between two or more bones. Okay? And there are several types of joints. Okay? The first type is a diarthrotic joint. Diarthrotic, di means two, right? So these are the joint connecting two bones. Okay? And usually there's a small space between the two bones. And this gives free movement of the joints. Okay? And the famous ones are the ball and socket joint and hinge joint. Let's take a look. The shoulder joint here is a ball and socket joint. Okay, let me see. The ball and socket joint. So if you look at the skeleton, there's a space, enough space for this to move. So, and this looks like a ball. Looks like a ball. So there's a ball and socket joint here. Similarly here, between the pelvis and the upper leg, this bone is, the head of the bone is like a ball. So this is a ball and socket joint here. And with this kind of structure, you are able to kind of rotate, turn like that. Okay. And for this joint, it's more like a hinge at the elbow. It's not like it's different. Okay. The motion is more restricted like that. It goes like that. It's like a door hinge. Like a door hinge. It closes and opens only. So this is a hinge joint. But again, there is some space. That is why you can do this. Okay? Okay, and the second type of a joint is a synarthrotic joint. Okay, usually there is no, not usually, always, no joint cavity, no joint space within. Therefore, immovable, such as skull. If you look at the skull, it's, yeah, there's, skull is actually, you can see the suture. You can see the suture line there. Okay. There are sutures that. So you know that there are several pieces joined together. So these are joints also. However, they don't move. You can, there's, because it's tightly joined. There's no movement, okay? Okay, let's take a 10 minutes break here, okay?